Hi, let's do this question. So here we are proving the angle at center circle geometry theorem. Okay, so we've been given a diagram with the center being O, and we've been asked to prove the theorem which states that the angle subtended by a chord at the center of the circle is equal to twice the angle subtended by the same chord at the circumference. So that means we are trying to prove that TOP, this angle here, is twice the angle 2KP. So that is that one. Okay, so what we're going to do to begin is to construct. So construction, draw KO. So let's draw KO. So it's going to be from K and extend through to O, and we'll go past that. So this then divides K and O into two equal angles. So this will be K1, that's K2, and this is O1, and this is O2. All right, so one thing you need to notice is that KO is a radius and TO is also a radius. So that means we have produced an isosceles triangle. And the same happens with KOP, where KO is a radius and OP is also a radius, meaning that this is also another isosceles triangle. Okay, so let us begin with the proof. So first step, we are going to say that the angle O1, that exterior angle over here, this one, will be equal to K1 plus T. So O1 is K1 plus angle T. And the reason for this is because of the exterior angle of a triangle. So exterior angle of triangle. And that is equal to the sum of the two opposite interior angles. Okay, so we said that we saw that KO and TO are radii. So therefore, K1 should be equal to angle T. And this is because they are angles in opposite equal sides. Basically, the angle subtended by equal sides, creating an isosceles triangle. Some people also say base angles of an isosceles triangle are equal. So because of this, that means that O1 will therefore be equals to twice the angle at K1. So we'd rather want to use K1 because remember in our proof we want to prove TKP. So that's why we are going with K1. All right, so that portion is done. We're going to do the same for the angle at O2. So O2 will be equals to K2 plus angle P. And you can see this is your K2, here's your angle P, and once again, it's because of the exterior angle of a triangle, because O2 is here. So exterior angle of triangle. Nice. And once again, because we have OKP being an isosceles triangle, it means that again K2 will be equal to angle P. And this is because angles opposite equal sides. Okay, they're base angles of an isosceles triangle. So because they're equal, similar thing happens here. We therefore have O2 being equals to twice the size of K2. All right, now back to our diagram. We've found an equation for O1 and something for O2. Let's combine them because O1 and O2 are what create TOP. So O1 plus O2 will be equal to, so we found O1 to be 2K1 and O2 to be 2K2. So we can now factor out the 2. That's our common factor. So we're therefore left with K1 plus K2. Okay, so we just found the sum of O1 and O2, and we know that O1 and O2, they create angle TOP. So therefore, TOP is equal to, and we know that K1 and K2 on the diagram, they form that angle TKP. And there we go. We have just proved the angle at center theorem.